Well, welcome AP Stats, kids. Here's a video for you. Not sure if you've been asking or not, but whether or not, here is one just in case we have early dismissal for snow today, which sounds like it might be a possibility. So what we were planning on looking at today is this lesson 10-1 day 3, the front side, where we're going to look at doing a significance test for the difference between two proportions. So we're going to start by reading the stem and pulling out what we need. It'd be a great idea for you to pause the video and for you to pull what you can out of the information we're given here at the beginning, and then check with what I do. All right, so here we go. According to phys.org, Black and Hispanic females are underrepresented in STEM programs compared to non-STEM programs. A certain university would like to see if this is true for their student population. They took a random sample of 300 STEM students and found that 12 were Black or Hispanic females. So if I take this first sentence here, they took a random sample of 300 STEM students, right? We have a random sample, that's key. We have a sample of 300 and they are STEM students, and we found that 12 were Black or Hispanic females. So as we look at this, there are a few things that are important to us. One is that our variable X is the number or the count of Black and Hispanic females. We have a population, and population 1 is all STEM students at this certain university. From that population 1, we have a sample 1, that has a size of 300, and of those 300, we have a certain count of 12 Black or Hispanic females. Right? So from that, we know that we have a sample proportion for that first population of 12 over 300, which is 0.04. So as we read on, we have now a separate random sample of 500 non-STEM students that had 75 Black or Hispanic females. So now we have a second population, that's key. Population 2 is all non-STEM students. At this same university, and the sample size we get from population 2 is 500, with the count of Black and Hispanic females from that population of 75, which gives us a sample proportion from population 2 of 75 over 500, which is 0.15. And then the question says, do the data provide convincing evidence that Black and Hispanic females are underrepresented in STEM programs? So from this statement, I have a job to do, right? I'm trying to determine if there is convincing evidence that Black or Hispanic females are underrepresented in STEM programs. And so what we're doing is we're comparing the proportion of Black or Hispanic people in STEM programs to those in non-STEM programs. So what we're really looking for is if there is convincing evidence that the true proportion of Black and Hispanic females from STEM programs is less than the proportion of Black and Hispanic people in females in non-STEM programs, right? So this is the key. How do we find convincing evidence? Well, we do a significance test. So from here, we're going to work through our state plan do conclude. It's a great time to pause the video and you make your statement. All right, let's see how you did. So here's our state. We want to what? To test the following hypotheses at the alpha equals 0.05 significance level. What are our hypotheses? We're going to state these two different ways. So our null hypothesis is that the females are not underrepresented in STEM programs. And so that would be that P1 is equal to P2, or that P1 minus P2 equals 0. Typically, when we do a significance test by hand without the calculator, we're going to want to take this as our null hypothesis because using 0 is easier. But if we're going to use our calculator, it's set up to take this first statement as our null hypothesis. So we want to be comfortable with both of those. For our alternative hypothesis, it would be that the proportion of people from STEM is less than the proportion of Black and Hispanic females from non-STEM. So that would be P1 is less than P2, or subtracting P1 minus P2 is less than 0. And again, you should be comfortable with both of those. Now, we're not done yet. So we now have to define any variables we're using. So P1 is the true proportion of Black and Hispanic females in STEM programs at this university, and P2 is the true proportion of Black and Hispanic females in non-STEM at this university. Okay, so that has all the classic statements that we want to make, right? We are testing, right? We are testing our hypotheses. Those are spelled out. We give our significance level, and we define our parameters. So there's our state. Let's move on. All right, pause the video and make your plan statement. Welcome back. All right, so here's our plan. In order to test those hypotheses, we will do a 2-sample, right, with proportions. We do z-tests, so a 2-sample z-test for P1 minus P2 for the difference between our proportion, right, if our conditions are met. So we address those conditions, the random condition. Okay. We were told that they took 2 separate random samples. Right. And that's in the stem of the problem. Right, that's a good way. We'll just stick those 2 words together. All right, let's try that again. 2 separate random samples. Okay. We did take samples, so we addressed the 10% condition, and we have that 300 should be less than or equal to 1/10 of all STEM students at the university, and that 500 should be less than or equal to 1/10 of all non-STEM students at the university. Now, we don't really know this to be true. They didn't tell us how big the university was, how many students they were, so we're going to make the statement that we assume this to be true at this university. So we have our random, we have our 10%. Let's address our final. With proportions, we do large counts. So we don't use expected counts here, we use actual counts because we're not comparing to an alternative proportion, we're just comparing the two proportions. And so we get that the number of failures or the number of successes we had from our STEM students was 12, and that was 12 out of 300, so that leaves us 288 failures. From the non-STEM, we had 75 successes, and out of 400, that left us 425 failures. So this would be females, males from STEM, females, males from non-STEM, and all of those are greater than or equal to 10. So that makes our large counts condition. So that's our plan. Now pause and do your do. Okay, so here we go. When we do a significance test, we find the value of our test statistic, our z-score, and we find our p-value. So let's look at this. For this, right, our z-score is found by taking p hat 1, which was 0.04, minus p hat 2, which was 0.15, and subtracting the null, which if the proportions of the two are equal would be 0. Right? And we divide that by the standard deviation of the sampling distribution for the difference in those two proportions, which is going to be what we call the pooled, or the combined, not the pooled, the combined proportion. The idea is this, that if there is no difference in the proportion of females in STEM programs compared to the proportion of Black and Hispanic females in non-STEM programs, then it's as though we are taking two samples from the same population. And so, since we're comparing against the null, we make that assumption that that's true, and we treat our two samples as really two parts of the same sample. And so, in order to do that, we find this combined proportion, right, which is from the two samples combined into one, by taking the counts from our first sample and adding the counts from our second sample together. So we're combining the total of females in both programs together, and then dividing that by the size of each sample. So in this case, we had, I think it was 12 Black and Hispanic peoples from the non-STEM program plus 75 from the STEM, right? And our sample sizes were 300 and 500. So if we add that together, we end up getting 87 over 800, which is 0.109. So when we come in here, right, our formula is to do this combined proportion as the assumption for the proportions from each part. So our standard deviation is going to be that combined proportion, 0.109, times 1 minus that, which would be 0.8991, divided by the first sample size, which was 300. And to that, we'll add, again, right, the proportion of the sample as if they were 1, which is the same thing, 0.109, times 1 minus that, 0.891, and we'll divide that by the size of the second sample, which is 500. That's how we find our z. So if we calculate that, we get negative 0.11 divided by 0.228, which gives us a z of negative 4.833. Now let's think about that z-score, right? That's a standardized z-score that corresponds to this difference in proportions. So if we look at a graph of that distribution, right, since we're looking at standardized, that would be with a mean of 0, right, and a normal distribution, so normal distribution standardized. So mean of 0, standard deviation of 1. So if I have a z of negative 4.83, and a normal curve typically goes out 3 standard deviations from the mean, then 4.83 is going to be somewhere around here. And my p-value then is the corresponding area to the left of that, which is going to be this area in here, which we know is going to be very, very small. It's quite a bit more than 3 standard deviations left of the mean. So, right, we anticipate that p-value being very small. And for us to find it, if you go to your z-table, right, you're going to find that there's not even a z-score as small as negative 4.83, and the closest z-score listed is negative 3.49, which gives a p-value of 0.0002. So from my table, my p-value I know is less than 0.0002, which of course is quite small. Now, to do this by calculator, we're going to do, right, so by calculator, we're going to do a 2-proportion z-test. You should go to your calculator and do this, and you're going to see that there are certain numbers you have to put in. You put in x1, for us is 12. You put in n1, which for us is 300. You put in x2, ours is 75, and n2, which is 500. You then address the null, and this is where it was important to recognize the 2 different ways. And the null on this always starts with P1 and then compares it to P2. For us, we're looking for where P1 is less than P2, and this is our alternative hypothesis. I'm sorry, not our null. So we do that in our calculator, and what our calculator gives us, right, is the same z. So it gives us z as negative 4.833, and it gives us a p-value of 0.00000656, so even smaller, which we anticipated. So we're ready for our conclude. And hopefully this is what you said, because our p-value, right, which is almost 0, is less than alpha, which was, actually, I'm not sure that this problem gave us an alpha. I think we established 0.05, right? Or for that matter, almost anything less than that. So we had a very, very small p-value. So because our p-value is less than alpha, what do? We reject H0. And if we reject H0, we do it because there is convincing evidence for our alternative, right, which we're going to spell out. So there is convincing evidence that the proportion, right, the true proportion of females, of specifically of Black and Hispanic females in STEM programs at this university is less than the proportion in non-STEM programs. Now I'm going to add a final statement. Right? The question was, are Black and females underrepresented? Right? And our answer would be yes. Right? So yes, Black and female, Black and Hispanic females are underrepresented in the STEM program. Okay, there's that. Your job is to do the back side of your 10.1 day 2 and day 3 worksheets.